Let's look at this question here. They give us three facts. The first is that ABC is an equilateral triangle. The second is that D lies on BC. And the third is that AD is perpendicular to BC. And then they ask us to prove that triangle ADC is congruent to triangle ADB. So how can we do this? Well, there are various ways to show congruence. We can use the third fact that AD is perpendicular to BC to show that there is a right angle in each triangle. So the one that we're most likely to use here is going to be right angle hypotenuse leg. Let's start off by showing that we've got right angles. So we can say that angle ADC equals angle ADB, and we can say this is because they're perpendicular. And we also know that angles on a straight line sum to 180 degrees. So that's the R. Then we need to show the hypotenuse. We can say that AB equals AC, equilateral triangle. So we can see that these are equal because it's an equilateral triangle. And finally the legs. There's a temptation to use the legs at the bottom here, BD and DC, but we can't do that. The reason is they would be equal as a result of congruence, not from any of the three given facts. So the facts would need to state that AD bisects BC or bisects angle BAC. So we need to be careful when we're doing this to use only the given facts in our proof, not an assumption, however obvious. So let's see what else we could use. Well, we can use AD. Line AD is shared by both triangles. So let's state that AD is shared. And then we can say, therefore, triangle ADC is congruent to triangle ADB by RHL. And that's part A done. Let's move on to part B. There are a couple of extra facts that we need to write down before we move on to showing that the BD equals a half of AB. The first thing that we need to show is that we've recognised AB equals BC from the equilateral triangle. The next point we need to recognise is that BD equals DC, and we get this from the proof of congruence on the previous part of the question. Now what can we do? Let's say that BD plus DC equals BC. Now we can substitute in. We'll keep BD because that's what we're looking for. We change DC to BD, that's from this line here, and this equals AB from the line above here. Then we can rearrange this by saying that 2BD equals AB, and from that BD equals a half AB as required. So you can see the substitutions more easily. I've highlighted in different colours where BC is substituted for AB and then where DC is substituted for BD. I hope that makes it clearer how I've done the substitutions and where they've come from. As a bonus question, let's look at this parallelogram. They tell us that E is the point where the diagonals AC and BD meet, and they want us to show that triangle ABE is congruent to the triangle CDE. We need to prove that these two triangles are congruent. How can we do it? Well, in this case, there's no right angles, so we're not going to be using RHL, so we have to use one of the other ones. Let's start by saying that AB equals DC, and this is because they're the opposite sides of a parallelogram. What else can we tell? So this is where some of the earlier rules you learnt about angles on straight lines can come in quite useful. Let's look at the first one. We know also that these two lines are parallel because it's a parallelogram. And this means that we can imagine a line going up here, down here, and up here, and then we would know that these two angles are equal. So from this, angle BAE equals angle DCE, and these are alternating angles, or alternate angles. Similarly, we can say that we've got another line coming here, up here, down here, So these angles here are also equal. Angle ABE equals angle CDE, and this is alternate angles as well. Therefore, we can finish this off. Triangle ABE is congruent to triangle CDE, and the reason by angle, side, angle. So we've got angle, side, angle, in that order.